It's May 1st, 2011, and I thought I'd try something different for the web page. This is my project to convert a C Inc. ESP504 radio from amplitude compandered single sideband to amateur radio use with single sideband. What I've done with this radio is I've replaced the main CPU with an Arduino. As you can see here, I have a 40-pin header with some hard drive cable, because it was easy to find, connected to various pins on an Arduino. And those pins control various functions such as programming the PLL, etc., etc. I've made a little bit of progress in the last couple of years, unfortunately, that I've been working on this. What I'll try to demo here is transmitting on my FT817 with a 222 transverter to the radio and transmitting with the ESP504, and we'll take a look at what the spectrum looks like on the output. Right now it looks like it's a solid carrier, but there's stuff to be tweaked. Currently the frequency that I have set up for this is 222.1 megahertz. The ESP504 right now is connected to a dummy load, which is connected to a power sensor and also to the input of my spectrum analyzer and frequency counter. So when I transmit with the ESP504, you'll hear a carrier. You probably won't be able to hear it on the video, but there's a little bit of audio coming through on it as well. So I'll go ahead and I'll transmit. W09U testing 1 2. You can hear the carrier come up on the radio, and if we take a look at the spectrum analyzer output, W09U test, and we can also take a W09U testing 1 2 3. We can also take a look at the frequency counter and see that it is definitely transmitting on 222.1. And with that carrier, I don't know if I believe this piece of homemade equipment. 18 milliwatts, but it's pulling 7 amps at 12 volts, so I don't know where the power is going right now. The heatsink is a little bit warm, so there's a little bit of a problem there. Considering that thing only claims 18 milliwatts, it's been accurate for other things. There's more work to be done. On the other side, if I turn the volume up on this a little bit, I can transmit with the 817 and I can hear my audio. Part of the problem is that there's some feedback with the audio being so close here. W09U testing 1 2. Testing 1 2 W09U. So you can see that it basically works. Some of the functions that the Arduino takes care of are sensing the push to talk. There are some analog to digital converter and digital to analog converter values that need to be set on a per radio basis for things like nulling the carrier. That might be all I need to do with this, but it seems as if I already have the voltage values set properly from when it was not converted. One of the other things that needs to be done with this radio, because it's using ACSSB, they used a DSP to accomplish this, and because I just want sideband, what I did is I just took a jumper, as you can see here, and jumpered over the 2 pins in the codec, a little bit close, that actually allowed it to do ACSSB. So with that, that entire problem is removed.